All right, for the second part of MAT 221, section 2.3, I wanted to look at the worksheet that we have here on limits. This is in the worksheet folder, and if we look at this actual document, let's look at ways that we can find these limits using, try to make it a little bit bigger here, using our limit laws and what we know. So let's look at the first thing here. I'm going to take my print pen here, and it says find the limit as x approaches 3 from the negative side. So if we look at this function as x is approaching 3, 1, 2, 3, from the left side, my targeting value looks like I have a targeting value of 2. I'm going to change my pen to blue so I can have a blue pen here. Now, what about as x approaches 3 from the right side? Well, it looks like the function is down here, so as I approach 3, 1, 2, 3, from the right side, looks like my targeting value is -2. So, if I look at these values and I say, okay, if the left-handed limit is +2 and the right-handed limit is -2, then we know that the both-handed limit, the limit as x approaches 3 from both sides, does not exist. Then it asks us for what is the value of the function at x equals 3. At x equals 3, the solid dot gives me the actual value of the function, which is equal to 1. All right, let's look at the second example here on the worksheet. It said, what is the limit as x approaches -2 from the negative side? So let's hear -2 is right here. As x approaches -2 from the left side, my targeting output value looks as though it is equal to 2. As I approach -2 from the right side, I also have an output value of 2. The right-handed limit and the left-handed limit agree with each other, therefore the limit as x approaches -2 is 2. Then it asks me, what is the actual value of the function at x equals -2? Well, I have a solid dot there, so that also equals 2. Here's a case where all four of these things are equal to the same thing. Let's move this up and look at examples 3 and 4. See if I can move this over a little bit too. So we want to know the limit as x approaches 1 from the negative side. So here's x equals 1. As x is approaching 1 for the negative side, my targeting value looks like it's a value of 3. As x approaches 1 from the positive side, it looks like my targeting value is a value of 2. Being that my right-handed limit and my left-handed limit do not agree, then the limit as x approaches 1 does not exist. And then it asks me, what is the value of the function at x equals 1? And the value of the function at x equals 1 is equal to the solid dot that is there, and that has a value of 2. All right, let's look at number 4. It asks for what is the limit as x approaches 0 from the left. My targeting value looks like -3. As x approaches 0 from the right, my targeting value still looks like -3. Let me erase what I have here so I can actually see it a little bit better. Then my limit as x approaches 0 must also equal -3 because the left-handed limit and the right-handed limit are agreeing with each other. And the value of the function also equals -3. So for number 5, on the next page, it says, what is the limit as x approaches 0 from the negative side? My targeting value looks like a y value of 3. What is my limit as x approaches 0 from the right? That looks like a targeting value of -2. The left-handed limit and the right-handed limit do not agree with each other. Therefore, the limit as x approaches 0 does not exist. What is the value of the function at x equals 0? It is equal to the solid dot at x equals 3. Or excuse me, y equals 3. Number 6. What is the limit as x approaches 2 from the negative side? I'm approaching 2 from the negative side. Looks like a targeting value of 1. I'm approaching 2 from the positive side. It looks like a targeting value of 1. The left-handed limit agrees with the right-handed limit, therefore the limit exists and is equal to that. Then it asks me, what is the value of the function at x equals 2? That's that solid dot. That equals 3. Going on to number 7, it says determine the limit. Let's see if we can do a limit by direct substitution first. This would be 3 times -1/2 squared times 2 times 1/2 minus 1. Those 2's will cancel. We get 1 minus 1 here would be 0. So I don't even have to evaluate this. The value of the function of this limit would equal 0. I can do a direct substitution because this is a polynomial function. What about number 8? The limit by direct substitution, if I put in -4 plus 3, and I take that to the 1997 power. Well, 4 minus 3 is -1. -1 to an odd power is equal to -1. So these I can do by direct substitution. How about number 9? Can I do a direct substitution? Let's put in -3. If I put in -3, I get -3 squared, which is 9, plus -3 times 4, which is -12, plus 3, over -3 squared, which is 9 minus 3. The numerator would give me 9 plus 3 is 12, minus 12 would be 0, divided by 6, which equals 0. 0 is okay in the numerator, so the value of this limit is equal to 0. What about number 10? Let's see if we can do a direct substitution. E to the 0 times cosine of 0, because we know that the limit of a product is equal to the product of the limits here. By direct substitution, e to the 0 is equal to 1. Cosine at 0 is also equal to 1. This equals 1 times 1, which equals 1. Let's do number 11. By direct substitution, I would get radical -2 minus 2. This is not in the domain. We get -4. We cannot find this one by direct substitution. This is not in the domain. Actually, -2 is not even in the domain of this function. It does not exist. Here, can I do a direct substitution? No, I cannot do a direct substitution because I get 1 over 0. 0 is not in the domain here. This is undefined. Numbers 12, 13, 14, and so forth. These ones we might have to do using Mathematica or when we talk about limits to infinity in section 2.4. So we'll hold off on those for now.